Okay, so I was saying we're going to look at how we calculate these elasticities of demand. Okay, so we've got this question here. Consider the following demand function QD equals 25P2. Show that the point elasticity of demand for the function is always equal to negative 2. Okay, so colleagues, point elasticity of demand, this is the formula for it. Okay. You're going to, this dq dp just means you're deriving the demand function. Okay. You're deriving the demand function, this dq over dp. Deriving the demand function with respect to q times the price over the quantity. So whenever they ask you for point elasticity of demand, this is the formula here. Okay. So we have to derive this function first. This function which we're given here, 25 over p squared. We have to derive it. So let me use my board here so that we can derive this. Since q equals 25 over p squared, right? According to the laws of indices, we can put this as 25p to the power negative 2. Okay, remember, according to laws of indices, a negative exponent, you get the reciprocal. So this 25 over p squared can be written as 25p to the power negative 2. All right. Now remember, with point elasticity of demand, we said it's dq over dp times the price over the quantity. So this is what we're going to derive, colleagues. Okay, this is what we're going to derive. So remember, this is how you derive using differentiation. Okay, you are going to multiply the exponent or the power, this negative 2, with the number in front of the letter. Negative 2 times 25, that is negative 50. Negative 50 p. Then this same power which multiplied with that 25, we're going to subtract a 1 from it. Negative 2 minus 1, that is negative 3. Okay. So we can write this as negative 50 over p cubed. Okay. Any questions with that? Okay. Then remember the point elasticity of demand, we said it's a dq over dp multiplied by p over q. So we've already got this. P over q, p is just the price, so you just say it's p over q is the same as saying p is the price, q is 25 over p squared. According to this question, q 25 over p squared. Okay, 25 over p squared. So to simplify this fraction, just remember the number at the denominator is always going to go on top. Do I need to show that, or we understand this already, such that it becomes p cubed over 25? Are we okay with this, colleagues, or should I show how this has happened? Okay. The same as saying P divided by 25 over P squared. Remember, whenever you are dividing fractions, the sign changes to multiplication. And when it becomes multiplication, the denominator goes to the numerator, and the numerator goes to the denominator. So you have P squared over 25. So P times P squared, that gives you P to the power 3 over 25. Okay, colleagues? All right. So now we solve. Since we said point elasticity dq over dp multiplied by p over q. Okay. So dq dp is negative 50 over p cubed multiplied by uh, p over q. We simplified it to p cubed over 25. Okay. These p's cancel each other, so we've got negative 50 over 25, which is going to give us negative 2. Okay. Because in the question, it says that you have to show that the point elasticity of demand, the function is always equal to negative 2. Okay. Yes. Any questions before we move further? Okay. We have this question here. It says, the demand for good X is 300 units when the price is 4 kwacha. Assume that as a result of the price fall, the demand of the good decreases to 400 units and the sales revenue falls by 400 kwacha. Calculate the price of the good after the fall. Okay, so with this type of question here, let me bring it here. First, take note of your prices and the quantities. Okay. Our our quantity 1 is 300 units. Our price 1 is 4 units. Our quantity 2 is 400 units. Our price 2, we don't know. Okay. We do not know. Okay. So first things first, let us calculate the total revenue first. Okay. Remember, total revenue is price times quantity. Okay. So you're going to say 4 kwacha times 300 units. Total revenue is 1,200. Okay, total revenue is 1,200. Now in the question, they told us total revenue falls by 400 kwacha. Okay, so it means this 1,200 is going to fall by 400 kwacha. Okay, so we can make this equation here because we need to find our new total revenue. Okay, which we're calling total revenue 2. So total revenue 2 equals total revenue 1 minus the 400 kwacha drop. Okay. So 1,200 minus 400, you get 800 kwacha. Okay, 800 kwacha is our new total revenue. Now remember, colleagues, in the question, we are trying to find out what is the new price of the good. Okay, so we have our total revenue too. We also have our quantity too. So it means we can calculate our new price, because remember, total revenue is price times quantity. So if the total revenue is 800 kwacha, price the price here P2, we'll label it as P2, and the new quantity is 400 units. Okay, you're going to say P2 times 400, that's 400 P2. To get the value of P2, divide both sides by 400. 800 divided by 400, that is 2 watt. Okay, so that is the new price. Okay, that is the new price of the good. So in the situation here, the initial price was 4 kwacha and quantity demanded was 300 units. Now when the price dropped to 2 kwacha, quantity demanded increased to 400 units. Any questions, colleagues? Okay, so now just ask where you are so that I know where to start from. Okay. Yes. No, no, no. Here we are not calculating price elasticity of demand. We're trying to find the new price. So, have you seen this situation here? Okay. The demand for good X is 300 units when the price is 4 kwacha. Assume that as a result of the price fall, the demand for the good increases to 400 units and the sales revenue falls by 400 kwacha. So the first question is calculate the price of the good X after the fall. So here, the way we got it, first find the initial total revenue. When the price is 4 kwacha and the demand for goods is 300 units, the initial total revenue was 1,200. Okay. Now they told us that the price dropped, the sales revenue, the total revenue dropped by 400 kwacha. So that 1,200, you deduct it by 400, okay, which gives you a new total revenue of 800 kwacha. Okay, madam. So now, since we've got the new total revenue and we've also got the new quantity, we can calculate the new price because remember the formula for total revenue is just price times quantity. Okay. So since we tabulated our new total revenue and we had our new quantity, so price equals total revenue over quantity. Okay. And the new total revenue was 800 units. The new quantity was 400 units. So that's how we calculated the price of 2 kwacha. Okay. Where we're calculating price elasticity of demand is the next part. Okay. Here, part 2. Calculate the price elasticity of demand with respect to the fall in its price. So, price elasticity of demand, this is the formula here, colleagues. This one here. So basically, we're just saying percent change in quantity demanded over percent change in price. Okay, colleagues? Percent change in quantity demanded over percent change price. Could you just mute your mic so that we don't have feedback? Okay. Yes. Percent change in quantity demanded over percent change in price. Now remember this, colleagues. Every time you're tabulating percent change, new the new value minus the old value over the old value times 100. Okay, that's how you get percent changes. In Remember this formula because you see it in you will need to use it in a lot of topics and other courses. Okay. Yes, this is the formula for any percent change. So if you want to find percent change in price in quantity first, it's the new quantity which is Q2 minus the old quantity which is Q1 over the old quantity which is Q1. That's a percent change in quantity. Okay. Percent change in price, new price P2 minus old price P1 over the old price P1. Okay. Just remember this, colleagues. If you remember the formula for percent change, you can apply it on this price elasticity of demand questions. Okay. So in this question here, our Q2, which is our new quantity, was 400 units, if I'm not mistaken. Our Q1, which was our original quantity, was let me see. What was okay? Q2 was 400, then Q1 300. Q2 400, Q1 300. Okay. The new price that we calculated, P2 was 2 kwacha. The old price P1 is 4 kwacha. Okay. So for this type of questions, this is all the data you need. The new price, old price, new quantity, old quantity. Then you find the percent changes. Okay, you find the percent changes. Okay, so if you find the percent change for quantity, new quantity 400 minus old quantity 300 divided by old quantity 300, you're going to get 0.3333, which means quantity demanded increased by 33%. Okay. This increase from 300 units to 400 units is a 33% increment. Um, the percent change in price, new price, 2 kwacha minus old price 4 kwacha divided by the old price 4 kwacha. 2 minus 4, that is negative 2. Negative 2 divided by 4, that is negative 0.5. Price dropped by 50%. Okay. Price has dropped by 50%, and the quantity demanded has increased by 33%. That's what's happening here. Price dropped by 50%, and quantity demanded has dropped by 33%. Okay. Now, colleagues, have you seen these lines that I've put here? With price elasticity of demand, these lines represent an absolute value. If you remember, according to the law of demand, there's a negative relationship between price and quantity demanded. Okay, meaning one variable will increase and the other variable will decrease. So, because of this negative relationship, every time you're calculating price elasticity of demand, you're always going to be getting negative values. Why? Because one quantity has increased, the other one has dropped. So you're going to always be getting negative values. So that's why we've put the absolute value, these lines here, okay, so that we ignore these negative values so that we can determine if price elasticity is elastic or it's inelastic. Okay, colleagues. Yes. Due to the law of demand, when tabulating this price elasticity of demand, you always get negative values. So that's why we are incorporating the absolute value. When you say absolute value, it just means ignore the negative sign so that you can interpret whether demand is elastic or inelastic. Okay. Because if we don't use these absolute values, every time your answers are always going to be demand is inelastic. Because its negative values are always less than 1. So it means every time you calculate, you just be getting negative values, and it means you just be interpreting, oh, it's inelastic, it's inelastic, which is not accurately true. So that's why we brought these, the absolute value. Okay. So I'm going to say 0.33 divided by negative 0.5, you get negative 0.667. So the absolute value, where we just ignore the sign, is 0.667. So let me tell you how to interpret this. When your price elasticity of demand is less than 1, then it means demand is inelastic. Okay, not sensitive. Okay, meaning price can increase by a big amount, quantity demanded would drop by a small amount. But if your price elasticity of demand is greater than 1, it means demand is elastic. It means demand is sensitive. Okay. And if your price elasticity of demand is equal to 1, it means the change in quantity demanded will be the same as the change in price. Okay, which is called unit elasticity. So if price increases by 1%, quantity demanded will drop by 1%. Okay. If price drops by 20%, quantity demanded will increase by 20%. So in this case, colleagues, since our value is less than 1, 0.667 is less than 1, it tells us demand for this good is inelastic. It's not sensitive to price changes. Okay. Even when we reached this point here, when we found these percent changes, you can easily tell if demand is elastic or inelastic. Price dropped by 50%. Quantity demanded just increased by 33%. Okay, so another trick you can use is this. If percent change in quantity is less than percent change in price, okay, demand is usually inelastic, like in this case here. Okay, even before you calculate your final value here, you just say, oh, the percent change in price is bigger than the percent change in quantity. So you just know I'm dealing with inelastic demand. Okay, and if percent change in quantity is greater than percent change in price, then it means demand is elastic, it's sensitive. Any questions, colleagues? Yes. Number three, assume that the cross price elasticity of demand for good Y, which is a complement to good X, is negative 1.5. Calculate the proportionate change in the demand for good Y as a result of the fall in the price of good X. Colleagues, this brings us to the other elasticity, cross price elasticity of demand. How the quantity demanded of one good is affected by the price of another good. That is what cross price elasticity of demand is. Cross price elasticity of demand helps us determine if goods are substitute goods or if goods are complementary goods. Colleagues, what are complementary goods? Not interchangeably, but together, used together. Because interchangeably means you can switch one for the yes. These are goods, yes. Yes, these are goods. Yes, these are goods used together. By themselves, they can be of less value. Bread and butter. Okay. If the price of bread goes up, are you going to buy butter? And also, if the price of butter goes up, are you going to buy bread? Maybe. Okay. Maybe. Okay. But that's how complementary goods work. If the price of one goes up, the quantity of the other one gets affected. That's how complementary goods work. Okay. So whenever your cross pricing, so this is what you need to remember. Cross price elasticity of demand XED. Okay. XED. If it's negative, goods are complementary. Okay, like in that example of bread and butter. Okay, if the price of bread goes up, you stop buying bread. It means if you're not buying bread, you're not going to buy butter. So it means the quantity demanded of butter is going to go down. So have you seen they're moving in opposite directions. That's why we say negative is for complementary goods. Okay. If the cross price elasticity of demand is positive, then goods are substitute goods. Okay. Think of Coca-Cola and Pepsi. If the price of Coca-Cola goes up, people stop buying Coca-Cola and then they'll switch to Pepsi. So what will happen to the quantity demanded of Pepsi? It will go up also, right? Madam Clover, Mr. Godfrey. If the price, imagine in this theoretical example, there were Coca-Cola and Pepsi. These are the only two drinks available. The price of Coca-Cola goes up. What happens? People stop buying Coca-Cola and substitute it with Pepsi, right? So what will happen to the demand for Pepsi? Yes, yes, that's correct. So have you seen it's like they're moving in the same direction, right? If the price of Coca-Cola goes down, it means it's cheaper than Pepsi. People buy more Coca-Cola, meaning quantity demanded for Pepsi is also going to go down. Why? Because people have substituted the Pepsi with the cheaper Coca-Cola. Okay, so if cross price elasticity is positive, you are dealing with substitute goods. Okay, so here's the formula for cross price elasticity of demand. Always percent change in quantities in on top. Percent change in quantity of good Y over percent change in price of good X. Okay, so here in this question, they told us this. Okay, yes, assume that the cross price elasticity of, mhm. Assume the cross price elasticity of demand for good Y, which is a complement to good X, is negative 1.5. Calculate the proportionate change in the demand for good Y as a result of the fall in price in good X. So if you remember, good X earlier on, we found the percent change in the price. Mhm. Are you able to get me here? Here's the question. Assume that the cross price elasticity of demand for good Y, which is a complement to good X, is negative 1.5. Calculate the proportionate change in the demand for good Y as a result of the fall in the price of good X. So, the formula for cross price elasticity of demand, percent change in quantity for good Y over percent change in price of good X. Now remember, earlier on, we found the percent change in the price of good X. Remember when we were calculating, is it this price elasticity of demand? When we did P2 minus P1 times P2 minus P1 over P1, we found this negative 0.5, which when you multiply by 100, it's negative 50%. So we already have the percent change in the price of good X. Now here what we're trying to find is what is the percent change in the price of good X. So have you seen how the formula is? We already have our cross price elasticity of demand, negative 1.5. We already have the percent change in good Y, negative 0.5. We want to find the percent change in X. Oh, in Y, and let me put this as Y. So you just cross multiply. Negative 1.5 multiplied by negative 0.5, you get 0.75. When you multiply this by 100, this is 75%. Okay. So that is the percent change in the quantity demanded of good Y. When the price of good X falls down by 50%, the percent change in quantity of good Y increases by 75%. Meaning, these goods are used together. So since the price of good X has dropped by 50%, it means more people will buy good X. Now, since good X and good Y are used together, it means since they bought good X, they also need to purchase good Y. That's why the quantity demanded for good Y has increased. Okay, because the price of good X has become lower, so people are buying more of good X. So as they are buying more of good X, they're also now going to need to buy good Y since they're complementary. That's why the percent change has increased. Okay. Yes. Any questions?